All right, hello everybody. This is Miss Piekarski, obviously, and this is the beginning of the Unit 9 notes. With this unit, it's going to be pretty long, and we are going to condense it quite a bit, so please, please, please keep up with your work, keep up with the videos, make sure you watch them all and take notes and everything. I'm hoping to be able to be done with this unit before the spring break, and in this unit, we're going to go over several different types of functions. One of them is called a power function. One of them is called an exponential function. And then the other one are logarithm functions. Okay. So I'm going to be jumping around in your notes quite a bit. This is the first page we're going to look at because we're going to first focus on our power functions. And today, we're just going to look at power functions, and then later on this week, we'll look at exponentials. So with power functions, you have formulas where your exponent is, your variable, x, is your base number, and you can, sometimes you'll have a leading coefficient, like this your a value may be a 2 or whatever, but you'll have some sort of power here. So this could be x squared, x to the third power, x to the fourth power, whatever. So that's why these are called power functions, because your variable x is raised to some power. Okay. So a couple of things: how the constant terms, your a value and your b value, how is growth impacted? Well, your b, if b is greater than 0, so like a 1 or 2 or 3 or 4, whatever, then you're going to have what's called growth, or an increasing function. And you can have so there's two examples here. In this case, if your b value, your exponent, is greater than 1, then your graph is going to start here at the origin, and it's going to go increase like this. Okay. If your b value is a fraction, let's say it was 1/2 or 1/3 or whatever, then you'll still start at the origin, and you'll increase like this, and it just kind of goes like that. Okay. So your initial conditions, where is the y-intercept? Well, it's at the origin. So if x is 0, then your y is also going to be 0. And then your end behaviors, no matter what your b value is, whether it's a number greater than 1 or a fraction, you're always going to be increasing. So as x approaches positive infinity, your y value is also approaching positive infinity. So it looks like this is going to increase much faster, and it will, but eventually here you're going to still keep increasing. You'll still keep going up like this, okay? So make sure you get this on the first page of your notes, and then flip over to the back of your notes for when your power function is decaying or decreasing. So notice up here where it says decay or decreasing. Again, you're still going to have a coefficient here and then an exponent here, and your variable is your base number. In this case, when b is a negative number, so maybe b is -2 or -3 or whatever, the graph looks like this, which kind of looks like a rational function, which we just got done with all the rational functions. So you should be familiar with this little shape here. And notice that your initial condition, you don't have a y-intercept. So it's undefined. You have a vertical asymptote when x is 0. You have a vertical asymptote. And then on the end behaviors, again, as x gets closer to 0, you're going to keep increasing. But on this end, as x approaches positive infinity, your y is going to approach 0 here. Okay, so you end up with vertical asymptotes. You have a vertical asymptote here at x is 0. You have a horizontal asymptote here at y is 0. Okay, that's essentially what a decaying power function does. All right, now let's flip over to a couple pages until you find, let me see. Oh, yeah, sorry. I was trying to remember where I was at. And I'm also trying to find the page in your notes. So let's see, 1 page, 2 pages, 3 pages, 4. Okay, so it's on your this is the 4th page of your notes. all the other tables that has like the law of cooling and stuff, we'll get to that later on. And then at the very end, I want to compare all the regular parent functions to compare and contrast. Okay, so find this page in your notes. It should start off with while the domain and range of some functions such as f of x equals x raised to the power of 1 over 3. All right, so again, you're increasing because your exponent is a positive number, but you have a fraction here. Okay, and so what that means or what that looks like is when you have any type of fraction here, what you have is a root of some sort. So this could be a square root. So let's say we had the square root of x here. What you could rewrite that as x raised to the 1/2 power. Okay, so anytime you have a fraction in your exponent, what you have is some sort of root. So if we had 1 over 3, this would be a cube root. So x raised to the 1/3 power would be a cube root, so you would have a 3 out here of x. Okay, so these indicate your roots, and there's a lot of times, whoops, let me fix that. There's a lot of times in this problem where we're going to have a number in the numerator and the denominator. And let's say we had the number, let's say that our fraction was 2/3 here. Then your x would be raised to the squared here, and then here would be your n value. Okay, these are formulas you're going to find in this unit. We're going to have a lot of formulas and patterns, and we're going to use m and n. You'll use an A and a B and a C. Okay, any number other than x and y, those are just going to stand for numbers. It can be any number. Okay, and so this is a pattern here. Anytime you have a exponent with a ratio or a fraction, your m value, that's the power that you're raised to. So you could have it x raised to the m power, and then your denominator is going to be your root. So maybe your square root or cube root or whatever. Okay, there's two ways that you can write that. You can write it like this or like this. Both of them, even if you type them in the calculator, both of them will give you the same answer. All right, moving on. You have a lot of these power rules, okay, or exponent rules. These should be a review. So anytime you have two numbers, let's say your base number is 2, so you have a 2 raised to the 3rd power times 2 to the 4th power. So your b and your c, those are your exponents, and a is 2. All you do is you add those two numbers together. So here you would just 2 to the 3rd power times 2 to the 4th power would just be 2 to the 7th power. And if you wanted to, you could plug that into a calculator and see that you get the same answer. Okay, here, when you have a to a raised to a power, then also raised to another power, then you multiply these two exponents together. Okay, so if we had a situation like this, notice you still have a 3 and a 4, 3 and a 4, but because of the parentheses here, then it's 2 to the 12th power, because 3 times 4 is 12, instead of 2 to the 7th power. Okay, and then let me see. What if you're dividing here? So here's your multiplying, here you're dividing, and notice here we added the two numbers together. Here you subtract the 2. Okay, so if you had 2 to the 3rd power divided by 2 to the 4th power, then you would just have 2 to the negative 1 power. Okay, and guys, you'll notice on all of these, I'm just plugging in numbers for my A, my B, my C, and my N value, and you can plug these into calculators individually and you'll get the same answers. So with this one, when you have two numbers under this root, you can separate those two numbers to get out. So you could have 5, or the 5th root of 2, or the 5th root of 3, and if you multiply those two together, you'll get the same thing as if you did the 5th root of 6. Okay, and then down here, if you have a fraction under a root, you can separate those fractions together and it's perfectly fine. Okay, part of this unit, you're going to learn how to simplify crazy equations like this and to simplify your answers. And so knowing these formulas or these patterns, I guess, will help you tremendously to simplify. So please, 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 if you don't have these memorized, at least know where in your notes to find them so you can use them. All right. So what do negative exponents indicate? They actually, amazingly enough, indicate reciprocals. So if you had, let's say you had x raised to the negative 2 power, what you would actually have is 1 over x squared, okay? And you can actually plug that into a calculator. Let's say we had x raised to the negative 2. You know what, let me give you values for x and for p. So let's say x was equal to 3 and p was equal to 2, okay? So if you had x to the negative 2 power, what you would actually, whoops, let me put that back to pencil. What you would actually have is, man, I replaced my x with a 3 and then I just wrote an x again. Sorry about that. So let's do, so if we had 3 raised to the negative 2 power, what we'd have was 1/3, whoops, nope, let me see, 1/3 squared here, which would just equal 1 over 9, okay? So if you have a calculator handy, plug in 3 raised to the negative 2 power, and then plug in 1 divided by 9 and see if you get the same answer. You will find that they are equal to each other. Okay, and I think, yeah. So that's the end of the notes for this section. Please, please, please have the 3 pages in your notes filled out and when you come to class tomorrow so that you will only have to do a few problems instead of a whole worksheet of problems. Okay, I will talk to you guys later. Bye.